Have you ever been puzzled by a piece of code that just won't compile? It can be incredibly frustrating, right? If that's you, then you're in the right place. Today, we're diving into the world of virtual base classes and why they must be constructed by the most derived class. I completely understand how confusing it can be when your code throws errors that seem to come out of nowhere. You're not alone in this struggle. Many developers face similar issues, especially when dealing with inheritance and virtual base classes. Here's the specific situation we're looking at. One user recently asked, why must virtual base classes be constructed by the most derived class? They provided a code snippet that fails to compile, and it raises an important question about class construction in C++. Let's explore this together. So what's going on here? When you use virtual inheritance, it changes how constructors are called. The most derived class is responsible for initializing the virtual base class to ensure that there is only one instance of it, regardless of how many times it appears in the inheritance hierarchy. And stick around. At the end of this video, I'll share a crucial tip that will help you avoid these kinds of issues in the future. To understand why virtual base classes must be constructed by the most derived class, let's first clarify what a virtual base class is. A virtual base class is a class that is shared among multiple derived classes, ensuring that only one instance of the base class exists in the inheritance hierarchy. Now, when the user creates a class that inherits from a virtual base class, like class B inheriting from class A, the responsibility of constructing class A falls to the most derived class, which in this case is class C. This is crucial to avoid ambiguity and ensure proper initialization. If the user tries to construct class A directly in class C's constructor without specifying the parameters, as seen in the original code, it leads to a compilation error. This is because the compiler expects the most derived class to handle the initialization of the virtual base class. By calling class A's constructor in class C's initialization list, the user ensures that class A is properly constructed with the required parameters. This is the correct approach and resolves the compilation issue. In summary, the user must remember that virtual base classes are designed to be constructed by the most derived class to maintain a clear and unambiguous initialization order. This design helps prevent multiple instances of the base class and ensures that all necessary parameters are provided. Fun fact: the concept of virtual inheritance was introduced to solve the diamond problem in C++. It's a clever solution that helps manage complexity in class hierarchies. Now let's look at the answers provided by other users. This user points out that the rule requiring virtual base classes to be constructed by the most derived class can be cumbersome. They explain that in normal inheritance, each derived class constructs its own base class. However, with virtual inheritance, the base class is constructed only once, and this happens in the most derived class. This means that the constructors of the intermediate classes do not have access to the base class, which is why the most derived class must handle its construction. Here's the tip I promised. Always remember to initialize your virtual base classes in the most derived class. This practice will save you from many headaches down the road. And there you have it. Now you understand why virtual base classes must be constructed by the most derived class. If you found this video helpful, please hit the subscribe button for more coding tips, and don't forget to check out our next video for more insights into C++ programming.